Okay, good day, grade 9s. I trust that you are well. This lesson is a short revision lesson that will prepare you for the Mathematics Paper 2, Section A paper. So it's just a short revision lesson. It's not limited to this content. Of course, you have to learn all the topics that I told you about, right, in class. Now, let's just minimize this. If I look at the screen, I can see I have a very interesting question, and already we are starting off with ratios, rates and ratios. Now, the question reads, I just quickly phrase this question. I could have worded it better if I could, but it reads, a car is traveling at a certain speed for a distance of 300 kilometers for 2 hours and 15 minutes. If the car travels at the same speed for 3 hours, how far did he travel? Very interesting question. So of course I can see three main points. The three main points, okay, let me get that out of the screen. The three main points that I can see, right, the three main points that I can see is distance, speed, and time. Distance, speed, and time. So there's a triangle that we can actually use to help us find with this question, right? So we can use this famous triangle D, S, and T, right? So from this triangle, if I block out, let's say I want to find the distance. So if I block out distance, I can see I'm left with S and T at the bottom. I know that distance is equal to speed times time, right? Remember, distance in this case is measured in kilometers, speed in this case is measured in kilometers per hour, and time is measured in hours in this instant. And speed is equal to, if I block out speed here, I can see that I'm left with distance and time. So speed is equal to distance over time. And lastly, if I block out time, time is equal to distance over speed. So these three formulas is quite important to actually answer this question. So let's tackle this question bit by bit. Firstly, a car is traveling at a certain speed, and I don't like that they say at a certain speed. What is that certain speed? For a distance of 300 kilometers for 2 hours and 15 minutes. So the first thing I need to do is find this speed value that they are talking about. But also, if I read the question, I can see that time is 2 hours and 15 minutes, but I just said that we are using hours to measure time. So let's convert this 15 minutes. Let's convert this 15 minutes into hours. So I like to use a table when it comes to conversions. We are looking for hours. We have minutes. I know that it takes 60 minutes to give me 1 hour. That's a given in our world. 60 minutes is the equivalent of 1 hour. So what will 15 minutes be equal to? Let's call it x. So I can actually create a ratio. A ratio is the same thing as a fraction. What is that ratio, you might ask? X is to 15 is equivalent to the ratio 1 is to 60. So a ratio is the same thing as a fraction, so I can form an equation. X over 15 is equal to 1 over 60. And let's solve for x. So how do I solve for x? I need to get rid of the denominator of 15, so I'll multiply the left hand side by 15 over 1, and I'll multiply the right hand side by 15 over 1. Quick algebraic recap is that when we multiply fractions, we multiply top with the top, bottom with bottom, numerator with numerator, and we multiply the denominator with the denominator. So 15 times x is 15. 15 times x is 15x, and 1 times 15 is 15. But I can just divide off the 15s. Basically, you can think of it as cancelling, but the correct word is divide off, because 15 divided by 15 is 1. So I'm left with x is equal to 15 divided by 60, right? And that will give you a nice decimal amount. I will not leave it as a fraction. It's 15 over 60, and that will give me 0.25 hours. So if somebody ever asks you what is 15 minutes in terms of hours, it is 0.25 hours. Right, excellent. So it looks like we're getting somewhere. Now moving on from there, we can see that of course, we are dealing with 2 hours and 15 minutes, which is 2 hours. So 2 plus 0.25 is 2.25 hours. So 2.25 hours is equivalent to 2 hours and 15 minutes. I have seen many learners who attempted to just say 2.515, which is incorrect, right? 2 hours and 15 minutes is 2.25 hours, right? And that is the time. So now, as we said, we want to find speed. So let me answer it here. Speed is equal to distance over time, which is equal to, the distance is 300 kilometers and the time is 2.25 hours. And what is that equal to? So let's use our calculator. We have 300 divided by 2.25, and that is equal to the speed. I'm going to round it up to 2 decimal places. 133.33 kilometers per hour, right? Then the question goes on. It says, if the car travels at the same speed. Now, what is that same speed? We just calculated it. It's 133.33 kilometers per hour. For 3 hours, how far did the car travel? Right? So now what are we looking for? Distance, the d value. So we know from our formulas that distance is equal to speed times time. So I can write it here. I can say distance is equal to speed times time. So the distance is equal to speed, which is 133.33. If you want, you can write the kilometers per hour, times the time, which is 3 hours. So I just have 3, and that is equal to, so of course the hours in terms of the units, they will divide off. So I'm just left with my answer, which is the answer here, which will be 399.99, right? So that's it. Now, if you want to be more precise, because we rounded this off early, you could have kept more decimals, and your final answer, I think, will be better to round off now if I look at it, right? So I think the final answer will be better to round off. It's always nice to keep as many decimals in your working out, and then your final answer can have that, that rounding off to 2 decimal places or 1 decimal places, depending on what the question actually requires. So let's see if we have more decimal commas. Let me just put the marker here. If we have more decimal commas, like 3, 3, 3, 3, as many 3's as we can, times 3, it will give me 399.999999, and if I round it up to 2 decimal places, it gives me 400 kilometers. So I think I'll leave my answer. As 400 kilometers. Right, so that was the question that we are dealing with. Let me just save this image. Right. Now, that being said, let us look at another example. Okay, that's not the right color. Right, okay. Now, that being said, let us look at another example. Of course, in your test, exponents play quite a large part. So let's look at an example of exponents. You need to know the laws of exponents. For example, when multiplying and the bases are the same, we keep the common base and we add the exponents. When dividing and the bases are the same, we keep this common base and we subtract the exponents. The second exponent subtracted from the first exponent, right? So, and remember, also recall that a fraction is the same thing as division. You need to know the further power rule. The exponents, you multiply the exponent to the further power, and do not forget to take the exponent that is outside and multiply to every exponent that is inside, including the exponent of the coefficient, which is very important. Now I'll show you what I mean with this example. Let's say we have let's take a simple example, right? Let's start with something a bit simple. We have negative 3x squared y raised to the power 5 times 2x. For some reason, I do not like that I have an x there, because the times and the x looks very similar. So let me just use a dot to show multiplication. 2x raised to the power 5 y times let's say negative 2x squared all squared, right? So nothing too complicated, right? So the first thing I'm going to do, I do not like this brackets here, so I'm going to get rid of this brackets. Now learners, they successfully say that this is equal to negative 2x raised to the power 4, but that's incorrect, because what about the coefficient? You need to also take that into account. So do not forget that negative 2 all squared is equivalent to negative 2 times negative 2, which is equal to positive 4. And notice that I included this in brackets because negative 2 squared will give me negative 4, but negative 2 all squared, when I include the brackets, it'll give me positive 4. So let's write this down. So it's negative 3x squared y raised to the power 5 times 2x raised to the power 5y, and remember there's an invisible exponent of 1 there, times 4x raised to the power 4. And now in this case, what I can do is I can multiply the coefficients, the coefficients together. So negative 2 times 2 is negative 6. Negative 6 times 4, that should be negative 18. If I'm not mistaken, yes, that should be, not negative 18. It should be negative 24, right? I don't know where my brain slipped on that one. So it should be negative 24, right? And now I can take x raised to the power of 2 times x raised to the power of 5 times x raised to the power of 4. Because I'm multiplying and the bases are the same, I can add the exponents together. So it's going to be x raised to the power of 2 plus 5 plus 4 times y raised to the power of 5 plus 1. And that is equal to negative 24 x raised to the power, that is going to be 7 plus 4, that should be 11, and y raised to the power of 6, right? And that is my final answer. Okay, so please do not forget about your laws of exponents. It's absolutely important. Now there's another nice question that I think is actually quite useful to you as well. So let's take a look at this, right? Let's say we are required to simplify. Let's say we are required to simplify this. I have in brackets 2 into x cubed times x raised to the power of 2, or raised to the power of 2, and all that is cubed. So this looks like it's a really long story. So let's first simplify everything in the brackets, and then we can get to this cube just a little bit later on. So firstly, we have 2, and inside of this we can just simplify this. Remember, when multiplying and the bases are the same, we add the exponents, the first law of exponents. So it's going to be x raised to the power of 3 plus 2, which is x raised to the power of 5 squared, and all that is still raised to the power of 3. That is equal to 2. Now I can apply the further power principle, which says that when an exponent is raised to a further power, we just multiply the exponent to that further power. So I have 2x raised to the power of 5 times 2, that should be 10, all cubed. And that is equal to, now I'm going to take the further power of 3 and I'm going to multiply it to every exponent inside the bracket. So it's going to be, I'm going to multiply 3 to the exponent of 2, which is 1, and I'm going to take 3 and multiply it to the exponent of x, which is 10, and that should be equal to 3 cubed, which 2 cubed rather, and remember 2 cubed is equal to 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, so that should be 8x raised to the power of 30. 10 times 3 is 30, and that is my final answer. Right, so let's look at another example, which I think is actually quite useful as well. Right, let's look at the following examples. Example, we are required to let's correct that. We are required to simplify the following. Right, now let me just get the question right. So this is 3, this is 2x plus 1 over 9x plus 1. So the question looks something like this. Now this is actually quite interesting, right? Because now I have 3 raised to the power of 2x plus 1, and I have 9 raised to the power of x plus 1. So the first thing I can do is I can rewrite 9 as a product of its prime factors, right? If you're not too sure, your calculator has a button. You just enter 9, press equal to, shift fact, or you can use the ladder method, but 9 should be 3 squared, right? If I rewrite 9 as a product of its prime factors, we looked at this in primary school, we looked at this in grade 8 as well. So now I have 2x plus 1 all over, and in brackets I'm going to rewrite 9 as 3 squared raised to the power of x plus 1. Very interesting. So this is equal to 3 raised to the power of 2x plus 1 all over. Now I can apply the further power rule. I'm going to take the exponent that is outside, and the exponent that is outside is x plus 1, and I'm going to multiply it by 2. So let's just visualize how that looks. 2 is being multiplied by x plus 1. And what law do we use in maths? And by the way, please recall your laws of exponents. The commutative property, you just swap the numbers around. The associative property, you group the numbers. And of course the distributive property of multiplication over addition and subtraction. In this case, this is the distributive property. The number that is outside and is being multiplied to the brackets, remember there's a multiplication between the 2 and the x plus 1. I need to distribute it to each term inside the brackets. So this is equal to 2x plus 2. So what do we have? We have 3 raised to the power of 2x plus 2. Right? Now what do we have here? This is actually quite interesting. Now we can apply the second law of exponents. When dividing and the bases are the same, we subtract the exponents. So I'm going to take this exponent and I'm going to subtract it to the exponent at the bottom. So this is equal to 3 raised to the power. The first exponent here is 2x plus 1 minus this entire exponent. Most common misconception, the most common mistake that I see learners make is that they will tell me that this is 2x plus 1 minus 2x plus 2. Incorrect. You need to subtract the entire denominator, the exponent of the exponent of the denominator, which is 2x plus 2. So I'm going to place it in brackets, and let me just write this in red. Brackets. I cannot emphasize the importance of this brackets more. And remember, there's actually an invisible negative 1 here. So I can apply the distributive property. I can take negative 1 and I can distribute it to each term inside the brackets. So it is equal to 3 raised to the power of 2x plus 1 minus negative 1 times 2x is negative 2x. Negative 1 times 2 is minus 2. Now I look for like terms. 2x minus 2x, of course that will be 0. Let me just use a different color so that you can see that, right? Basically 2x minus 2x is 0. 1 minus 2, what is 1 minus 2? It's negative 1, so it's 3 raised to the power of negative 1. And please do not forget the law of exponents that states that if I have a raised to the power of negative n, it is equal to 1 over a raised to the power of positive n. So I can rewrite this, my final answer, as 1 over 3. Let me just circle that quite nicely. Right, 1 over 3, and that is my final answer from there. So yes, I'm just thinking if there's any other example I should discuss with you at this point, but please go over all the content you can, all the revision we have looked at as well, and you should be fine. So I do wish you all the best for your studies. Thank you, grade 9s.